Okay, grade 8 probability. This is your second section from the textbook, section 11.2. These are now using a new method for calculating possible outcomes. It doesn't talk about probability of events happening, but rather just possible outcomes. So it says Jasmine wrote numbers 1 to 10 on 10 small pieces of paper and put them in a bag. She drew one number from the bag, and at the same time, she flipped a coin. Used three different methods. Well, the first method we could use is a tree diagram. So I could put the numbers 1 through 10. So if we finish our tree diagram, we can see here that each of these branches, this is one and heads, one and a two and heads, two and a tails, three and a heads, three and a tails, and so on and so forth. So altogether, there are 20 possible outcomes when I use a tree diagram. And if I wanted to, I could tell exactly which ones those are. If I wanted to use a table, I could use a table and also determine that there's 20 possible outcomes, and we can see the sample space in here, all of them in here. But the new outcome for calculating probability is to take the two events, event 1 and event 2. Event 1 would be, we can call it the drawing from the bag, which is 10 possible outcomes. Event 2, which is flipping the coin, which is 2 possible outcomes. And what we learned is, instead of doing the tree diagram or the sample space or the table, if we multiply those two together, we can determine possible outcomes through this method instead. The downfall to using this method is it doesn't show you what the possible outcomes are. By using a table or a tree diagram, we can physically see what those possible outcomes are, but this way it just tells us what the possible outcomes are, how many there are. Okay, next question. A coin is flipped and a six-sided dice is rolled, and a marble is randomly selected from a bag containing a black, a yellow, and a red marble. So I'm going to make this a little smaller first. Draw a tree diagram to organize the outcome. So here's what your tree diagram would look like. So when we do our tree diagram, we can see here that there are a 1 heads black, a 1 heads yellow, and so on and so forth of it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 times another 18. There are 36 possible outcomes. And it says use the multiplication method to verify this answer. So if we take our three probabilities again, so event 1 would be the coin flipping, which is 2 outcomes. Actually, I did my dice first, so I'll use that as my first outcome. So the dice would be 6 outcomes. Heads, tails would be 2 possible outcomes, and the blue, yellow, and red marbles are 3. So 6 times 2 is 12, and 12 times 3 is 36. We get the same number of possible outcomes using a tree diagram as we do using the multiplication method. Question 7 says, Tony has 4 different pairs of pants and 6 shirts. That doesn't seem like a very large wardrobe. But anyway, how many shirt-pant combinations can he make? So if we take the first one of being 4 pairs of pants and the second one being 6 different shirts, and we realize that the multiplication of those two would give us the number of possible outcomes, he has 24 possible combinations he can make. And that's the answer for 7. For 11, it says make up a question you would use for this thing. I can make, okay, I have a bow tie, or I have a regular tie, which is a necktie, I guess. I have khakis. I think I spelled those right. I have jeans. I have shorts. And I have dress pants. And then I have a white shirt, a blue shirt, a black shirt, a gray shirt, and an orange shirt. Why not? So if this was my question, how many combinations would I? One combination would be a bow tie with shorts and that orange shirt. That would be one combination. Or a bow tie with khakis and a white shirt. If we take those individual probabilities, there are 40 different combinations of clothing I could wear using that example. For the 15th question, it says determine the number of 4-digit numbers that contain only the digits 1, 2, 3, and 4. So if I think of a 4-digit number, a 4-digit number would have a ones place, a tens place, a hundreds place, and a thousands place. Right, a 4-digit number. And each one of these numbers could either be the digits 1 to 4 in each of them, which means there are 4 possible numbers that can go in the ones place. There are 4 in the tens, there are 4 in the hundreds, and there are 4 in the thousands. So if we learn to calculate overall possible outcomes by multiplying them, I really would have, if I take my calculator, I could go 4 times 4 times 4 times 4, and that equals 256. Another way I could do it is go 4, and right here, this button right here is the XY button. If I press that, the 4, it's treated as the base. If I put a 4, that treats it as the exponent, and if I press equals, it tells me the same thing. So 4 to the exponent of 4 is the same thing as 4 times 4 times 4, which means there are 256 different numbers that can be created with a 1, 2, 3, or 4. Question 16 says, how many car license plates can be made if the first 3 characters are letters and the last 3 characters are the digits 2 through 9? So again, we have 6 parts to our license plate. There are 26 letters in the English alphabet, which means there are 26 times 26 times 26 for letter combinations. And then multiply that by 2 through 9, which is 8 different numbers that are 2 through 9. So if I take my calculator again, I go 26 cubed, which is 26 times 26 times 26, times 8 cubed equals 8,998,912. Now all I had to do was go 26 times 26 times 26 times 8 times 8 times 8. I'll get the same answer. I just used the fancy buttons on the calculator to get the same answer. And we already did that one, didn't we? Yes, we did. All right, that was section 10.2. Next section, the next video is going to be on 10.3, which is calculating overall probability.